25th April 1945. Burma. Jungle terrain approximately 80 kilometers behind Japanese lines. Lieutenant Carter Harmon pilots Sikorsky R-4B helicopter serial number 4345286. The helicopter hovers at approximately 3 meters altitude. The rotor blades chop through humid air. The engine. A Warner R5507 cylinder radial producing 185 horsepower. Runs at maximum continuous power. The vibration is severe. The noise is deafening. The controls require constant attention. Below the helicopter, 4 British soldiers wait. They are survivors of a transport aircraft crash. They have been behind enemy lines for 3 days. Japanese patrols are searching for them. Rescue by ground forces is impossible. The jungle is too dense. The terrain is too difficult. Conventional aircraft cannot land. The only option is the helicopter, the experimental, unreliable, barely functional helicopter that Harmon has been flying for exactly 17 days. Harmon descends carefully. The jungle clearing is small. Trees surround the open area. The helicopter has no margin for error. If rotor blades strike trees, the aircraft will crash. If the engine fails, the aircraft will crash. If the controls malfunction, the aircraft will crash. The R-4 is so fragile and temperamental that any mistake is fatal. But Harmon has no choice. The soldiers need rescue. The helicopter is the only way. The helicopter touches down. 1 soldier runs to the aircraft. Harmon has already shut down the engine. The R-4 can carry only 2 people total, pilot and 1 passenger. The soldiers weigh too much for multiple passengers. Harmon will have to make 4 trips. He loads the first soldier. He starts the engine. He takes off. He flies to friendly territory. He lands. He returns. He repeats the process 4 times. 4 trips. 4 takeoffs and landings in jungle clearing barely large enough for the helicopter. 4 opportunities for mechanical failure or pilot error. All 4 trips succeed. All 4 soldiers are rescued. The mission takes approximately 8 hours total. Harmon flies the R-4 to its absolute limits. The engine overheats. The transmission temperature exceeds safe limits. The rotor blades flex alarmingly, but the helicopter functions. The soldiers are saved. This is the first documented combat rescue by helicopter. This is the mission that proves helicopters are not just experimental curiosities. They are operational tools. They can save lives. They are the future. This is the story of the Sikorsky R-4, the first practical helicopter. The aircraft that transformed from laboratory experiment to combat lifesaver in less than 4 years. The machine that Igor Sikorsky designed, the military tested, and Carter Harmon proved in the jungles of Burma. The helicopter that began the rotary wing revolution. To understand the R-4, you need to understand both the history of helicopter development and the specific circumstances that brought experimental aircraft to combat in 1944. Helicopters had been attempted for decades. The concept was simple. Vertical flight using rotating wings. But the execution was nearly impossible. Early designs failed. They could not generate sufficient lift. They could not control the flight. They could not solve the torque problem. When the rotor spins one direction, the fuselage wants to spin the opposite direction. Every early helicopter either could not lift off or spun uncontrollably when it did. Igor Sikorsky solved these problems. Russian immigrant, experienced aircraft designer. He had built helicopters in Russia before World War I. Those attempts failed. But Sikorsky learned. He immigrated to America. He built successful fixed-wing aircraft. He founded Sikorsky Aircraft. In the late 1930s, he returned to helicopters. This time, he succeeded. The key was the tail rotor, a small vertical rotor at the tail of the aircraft. The tail rotor produced thrust perpendicular to the main rotor. This thrust counteracted the main rotor torque. The fuselage stayed stable. The pilot could control the aircraft. The tail rotor was the solution that made practical helicopters possible. The Sikorsky VS-300 first flew in September 1939. The aircraft was experimental. It could barely hover, but it proved the concept. Sikorsky refined the design. By 1941, the VS-300 could hover stably, translate horizontally, and land safely. The helicopter was functional. Sikorsky demonstrated it to military officials. The Army Air Forces were interested. The military contract specified a practical helicopter. It must carry pilot plus 1 passenger. It must have range of at least 100 kilometers. It must operate from unprepared surfaces. It must be reliable enough for regular operations. Sikorsky accepted the contract. The result was the R-4. The R-4 first flew in January 1942. The design was similar to the VS-300 but refined. The fuselage was enclosed. The engine was the Warner R550 Super Scarab, 7 cylinders, air-cooled radial, 185 horsepower. The main rotor was approximately 11.6 meters diameter. The tail rotor was approximately 2.4 meters diameter. Empty weight was approximately 950 kilograms. Maximum takeoff weight was approximately 1,220 kilograms. The performance was modest. Maximum speed approximately 120 kilometers per hour. Cruise speed approximately 90 kilometers per hour. Range approximately 210 kilometers. Service ceiling approximately 2,400 meters. Endurance approximately 2 hours. These numbers were inferior to any fixed-wing aircraft. But the helicopter could do what fixed-wing aircraft could not. Vertical takeoff and landing. Hover. Fly slowly in any direction. Land in spaces too small for conventional aircraft. The controls were complex and physically demanding. The pilot had 4 primary controls. The collective pitch lever controlled vertical movement by changing the pitch of all rotor blades simultaneously. The cyclic stick controlled horizontal movement by changing the pitch of individual blades as they rotated. The tail rotor pedals controlled yaw by changing tail rotor pitch. The throttle controlled engine power. All 4 controls required coordination. Flying the R-4 was exhausting. The reliability was poor. The engine overheated regularly. The transmission vibrated excessively. The rotor blades cracked from stress. Control linkages failed. The aircraft required constant maintenance. For every flight hour, approximately 20 maintenance hours were required. The R-4 was operational only in the loosest sense. It flew, but it was always breaking. Despite these problems, the Army Air Forces ordered the R-4 into limited production. Approximately 130 were built. Most were used for training and evaluation, but a few were sent to combat theaters. The British Royal Air Force received several. One was assigned to 1st Air Commando Group in Burma. This aircraft, serial number 4345286, would make history. The 1st Air Commando Group operated in Burma, supporting Allied forces fighting Japanese. The unit used unconventional tactics and equipment. Light aircraft for reconnaissance, transport aircraft for supply drops, fighters for ground attack, and 1 helicopter. The R-4B assigned to the group arrived in March 1945. Lieutenant Carter Harmon was assigned to fly it. Harmon was experienced fixed-wing pilot. He had flown L-1 and L-5 liaison aircraft, but he had minimal helicopter experience. He received brief training on the R-4, approximately 10 hours total flight time. Then he was declared operational. He was the only helicopter pilot in the theater. He would fly the only helicopter in combat in the China-Burma-India theater. The first mission came in April 1945. A liaison aircraft crashed in jungle behind Japanese lines. The crew and passengers, 4 British soldiers, survived. They radioed their position. Ground rescue was impossible. The jungle was impenetrable. Japanese forces controlled the area. Conventional aircraft could not land in the dense jungle. The helicopter was the only option. Harmon flew the R-4 to the crash site. The flight was approximately 80 kilometers each way. The helicopter cruised at 90 kilometers per hour. The flight took approximately 50 minutes outbound. Harmon navigated by map and compass. No radio navigation aids existed. He flew low, following terrain features, avoiding Japanese positions where possible. The crash site was in small clearing. Harmon circled. He assessed the landing zone. The clearing was barely large enough. Trees surrounded it completely. The approach was vertical only. No running landing was possible. Harmon descended carefully. He hovered. He judged the clearance. The rotor disc was 11.6 meters. The clearing was perhaps 15 meters across. 3 meters clearance on each side. Harmon centered the helicopter. He descended. The helicopter touched down. The survivors ran to the aircraft. Harmon explained the limitation. Only 1 passenger per trip. The R-4 could not lift more. The soldiers understood. The lightest soldier boarded first. Harmon took off vertically. He climbed to approximately 100 meters. He flew back to Allied territory. The flight took 50 minutes. He landed. The soldier disembarked. Harmon refueled. He returned to the crash site. 4 trips total. Each trip was approximately 50 minutes each way. Plus time to land, load, takeoff. Each complete cycle took approximately 2 hours. 8 hours total for all 4 soldiers. During this time, the R-4 operated continuously at maximum power. The engine temperature exceeded limits. The transmission temperature was critical. The rotor blades vibrated dangerously, but the helicopter functioned. All 4 soldiers were rescued. This mission proved helicopters had military value. The rescue was impossible by any other means. Ground forces could not reach the site. Fixed-wing aircraft could not land, but the helicopter could. The vertical capability was decisive. The R-4 was slow, fragile, unreliable, but it saved lives conventional aircraft could not save. Additional missions followed. Harmon flew wounded soldiers from forward positions to field hospitals. The helicopter could land next to combat positions. Wounded could be loaded immediately. Flight to hospital took minutes instead of hours. Survival rates improved. The helicopter was not just rescue tool, it was medical evacuation platform. The concept of helicopter medevac was born, but the R-4 was not suited for sustained combat operations. The reliability was too poor. The payload was too limited. The range was too short. The performance in hot weather was inadequate. Burma in April and May was hot and humid. The helicopter struggled. Engine power decreased. Lift decreased. The aircraft could barely hover at midday. Harmon flew mostly in early morning or evening when temperatures were cooler. The maintenance was constant. After each flight, mechanics inspected the aircraft. They found cracks, wear, loose fittings. They repaired what they could with available parts. When parts were unavailable, they improvised. The R-4 was held together partially by ingenuity, but it kept flying. The missions were too valuable to ground the aircraft over maintenance issues. By June 1945, the R-4 in Burma had flown approximately 75 missions. Approximately 20 were rescues or medevacs. The rest were reconnaissance, communication, and supply missions. Total flight hours were approximately 120. For every flight hour, approximately 30 maintenance hours were expended. The maintenance burden was enormous, but the capability justified it. When the war ended in August 1945, the R-4 program was already being replaced. The Sikorsky R-5, a larger and more capable helicopter, was in production. The R-6, another improved design, was also available. The R-4 had proven the concept, but it was obsolete by the time the war ended. The aircraft that pioneered helicopter combat operations was retired within months of proving its value. The legacy was permanent. The R-4 demonstrated that helicopters could perform missions impossible for fixed-wing aircraft: rescue in inaccessible terrain, medical evacuation from forward positions, reconnaissance in areas without landing zones. The helicopter's unique capabilities made it an essential military tool. The Korean War saw extensive helicopter use. The H-19 and H-13 helicopters evacuated thousands of wounded. The survival rate for serious wounds increased dramatically because helicopters reduced evacuation time from hours to minutes. This capability descended directly from the R-4 missions in Burma. The Vietnam War made helicopters central to operations. The UH-1 Huey became symbol of the war. Thousands of helicopters transported troops, supplies, and wounded. The tactics were developed from lessons learned with the R-4. Vertical assault, medevac, reconnaissance, supply, all pioneered with the fragile experimental helicopter that Carter Harmon flew in Burma. Modern military operations depend on helicopters. The AH-64 Apache provides attack capability. The UH-60 Black Hawk transports troops. The CH-47 Chinook carries heavy cargo. Specialized helicopters perform search and rescue, special operations insertion, medical evacuation. The entire rotary wing ecosystem descended from the R-4, but the R-4 itself was terrible aircraft. Underpowered, unreliable, maintenance intensive, limited payload, short range. Every specification was inadequate. The helicopter was experimental technology forced into operational use before it was ready. That it worked at all was remarkable. That it saved lives was miraculous. That it convinced the military to invest in helicopter development was its greatest achievement. Carter Harmon continued flying helicopters after the war. He became commercial helicopter pilot. He advocated for helicopter development. He told the story of the Burma rescues to demonstrate helicopter capability. His advocacy helped secure funding for improved designs. His missions in the R-4 provided evidence that helicopters were worth the investment. The survivors of the Burma rescues never forgot. They had been saved by a machine that should not work. They owed their lives to fragile helicopter and determined pilot. After the war, some of them met Harmon. They thanked him. He deflected credit to the helicopter. The machine had functioned. He had simply operated it. But they recognized that his skill kept the fragile helicopter flying when any mistake would have been fatal. This is the complete story of the Sikorsky R-4, the first practical helicopter. The aircraft that proved vertical flight was operationally viable. The experimental machine that became combat lifesaver. The helicopter that was obsolete when it proved its worth, but established the foundation for all rotary-wing aircraft that followed. 130 built. Perhaps 75 combat missions, 20 rescues and medevacs, 120 flight hours in Burma. Underpowered, unreliable, fragile, but functional enough to save lives. Terrible aircraft that accomplished impossible missions. Experimental technology that changed warfare. The R-4 was not good helicopter. It was barely adequate helicopter, but it was helicopter at all. In 1945, that was revolutionary. The ability to land anywhere, retrieve wounded, and fly them to medical care in minutes rather than hours saved lives that would have been lost. The capability justified the limitations. The R-4 predicted the future, not through advanced technology, through proof of concept. Helicopters work. They can perform missions fixed-wing aircraft cannot. They are worth developing despite current limitations. The R-4 provided this proof. Every helicopter since has benefited from that proof. The birth of the chopper, the first helicopter in combat, the first documented helicopter rescue, the machine that transformed from experiment to lifesaver in jungles of Burma, the aircraft that was terrible but sufficient, the helicopter that changed everything. That is the Sikorsky R-4, the pioneer, the proof of concept, the terrible helicopter that saved lives and convinced the military that rotary-wing aircraft were future. 130 built, retired within months of war's end. But legacy permanent. Every helicopter ever built owes existence to the R-4, the experimental aircraft that worked just well enough to prove the impossible was possible. The birth of the chopper, the first in combat, the proof that helicopters save lives. That is the R-4. That is its legacy. Terrible aircraft, revolutionary capability, foundation of rotary wing aviation, the helicopter that was barely adequate but changed warfare forever.